Hi guys, my name is Chris, and in today's video I'm going to be showing you how you can dump firmware off of almost any embedded device that has a flash chip. So let's get started. But before we begin, you're going to need some tools, and these tools are a programmer. I have a CH341A here that has been voltage modded. You're also going to need some tweezers, SOP8 to dip package, hot air station, and that's pretty much it. So to dump the chip, we must first find it, and to find it we'll be looking for some small chips or some chips that are closer to the CPU. So I'm going to switch to my microscope and we can take a look. So here we are under the microscope, and we can take a look and try to find the flash chip. So I will look at different chips and we can figure out if they are the flash chip. So the first two chips I found are some kind of, they look like MOSFETs because they are closer to the DC jack and they have a lot of capacitors, inductors, and so on. So I think these two are MOSFETs for the stepping for the powering of the CPU and other chips. This is probably some Ethernet controller because it is connected to these transformers that do electromagnetic magic to the Ethernet. This is the RAM because it is connected to the CPU and is this big package. And here, this looks like the flash chip. It is made by Winbond and the serial number is 25Q16BV6. And Winbond makes flash chips, and the 25Q means it is a flash chip, and the 16 means that it is 16 megabits. So if you divide 16 by 8, you get 2 megabytes. And that's the flash chip. So you might look at some other device and the device might have some different chips because this is a SOP8 and flash chips can look different. For example, I have a Cisco router here, and if you take a look here, I will rotate it. Here is also a flash chip and it is in SOP16 package. So to better find the flash chip, I usually just Google the serial number and the manufacturer and look at the data sheet and see if that is the flash chip. So back to this board. Here we are. So now I will add some flux to the chip and I will desolder it. I will add some flux. And now I will just turn on my heating gun. And desolder it. I will rotate the board so it is easier for me to So here we are, the chip has been desoldered and we can look at the chip more closely. I will focus the microscope. we can see that the legs are okay, and I will just clean the chip so that I don't have flux in my adapter. And now that the chip has been desoldered, we can put it into the adapter. So we first must look at the chip and we must find the dot. The dot means for the pin 1. So I know that the dot is here, so this pin is pin 1. So I'm going to look at the programmer, and it says that 25 SPI has pin 1 here because of this notch. So this is pin 1. I'm going to rotate it, open it. This one is the right socket. Put it in there. Take the chip. Find pin 1. Open the adapter. Push the chip in. And I will take a look at the legs. If they are making contact. And it looks that they are. So now I will just plug this programmer to my PC and we will try to dump the firmware. Now I will just open AS Programmer, select the adapter that I'm using, select the chip that I'm trying to read, and that is the Winbond chip, and I will just press read to read the chip. Now that the chip has been read, we can take a look at its contents. We can see some strings and some data. Now I will just save the contents to a binary file, and we can later take a look at it with binwalk. Now that the content has been saved, I can just close AS Programmer and try to analyze the firmware with binwalk. I will just go to the folder and run binwalk on the firmware. Binwalk found some stuff in the firmware and it looks like it is only some strings, some copyrights. So I just soldered back on the chip and we can take a look in the UART if it was successful. So I will just connect my USB to TTL. And this, I can't quite remember. I think this is the, no, this is the TX, and this should be the RX. And I will just connect my ground. And I will connect the TTL to my computer.
Now I will just open PuTTY and I will connect to the adapter with the baud rate we found in the previous video, and that was 38,400. Now I will just power on the board and wait for the bootloop. The bootloop is starting to show, and it looks like the soldering was a success. We can see some stuff. We can even see the boot menu. I will just try some numbers, but they still don't work, but the routing table works. So that's pretty much it. Thank you for watching and see you next time. Bye.